Hey everybody, Diagnostic Derek here. Got a little bit of an older car today. This is a 2000 Toyota Corolla with a 1.8 liter. Don't see too many of these anymore. This one's in amazingly great shape, clean, well maintained. It's only got about 110,000 miles on it. But check engine light is on. Customer brought it in wanting to get it checked out. We've got a P0171 fuel system lean bank 1 code. My experience with most 4-cylinder Toyotas is that code is usually either caused by a vacuum leak or a bad or dirty mass airflow sensor. So in order to figure out which one of those we're dealing with, the first thing I'm going to do is take a look at the freeze frame data and see what was going on when the code set. So let's do that first. So looking at a freeze frame here, this code set on the engine was warm, 2700 RPMs. We scroll down here and we look our fuel trims when the code set. Short term was -9, but long term was +40 almost. So really about 30% positive correction on a warm engine under load, 46 miles an hour going down the highway. So that tells us quite a bit about what's going on here. So if the code set under load, turning almost 3,000 RPMs going down the road, we're not looking for a vacuum leak. Vacuum leaks happen at idle. We're looking for a dirty or a failed mass airflow sensor. So the other thing we can do is take a quick look at live data. If it's a dirty mass airflow or a bad mass airflow sensor that's underreporting, our fuel trims are going to be pretty decent at idle, and then when we raise the RPMs or put the engine under a load, they're gonna start to climb. So yeah, sure, we'll go ahead and do that real quick. So we've got the fuel trims pulled up on the screen here, and we're at idle right now. Our fuel trims are a little high, about 11-12% total trim. Taking a look at our mass airflow sensor up here, 1.85 grams a second. Now the rule of thumb that I like to use for mass airflow sensors is at idle, your mass airflow sensor should be reading 1 gram per second per liter of engine displacement per 500 RPMs. So a 1.8 liter engine, which is what we have, at 500 RPMs should read about 1.8 grams a second, but we're actually at about 700 RPMs at idle here, so that 1.8 grams a second is a little low, but our total trim is about 11% here. So what I'm going to do is I'm going to put it in gear and brake torque it a little bit, kind of load this engine, and look at those fuel trims start to climb. They start to go up right away. So pretty good indication that we're dealing with a mass airflow sensor problem here. I think what we'll do next is we'll pull the sensor out, take a look at it, see if it's dirty. Maybe we can get away with just cleaning it, and if so, we'll clean it and then check our trims to see if they're looking better, and we'll go from there. I'm not sure if I'm going to be able to get this on the camera or not, but what we want to do is look down inside the sensor at those wire filaments, and they're not terribly dirty. They've got a little junk on them. We'll go ahead and clean it up with a little mass airflow sensor and then check our trims again and see if they've improved at all. Okay, I cleaned the mass airflow sensor, reinstalled it, and I cleared the codes. So now I'm looking at the fuel trims, and we do see our mass airflow grams a second reading came up some. We're up to 245, which that's better. Looks like our idle fuel trims are a little better than they were. We were at about positive 11% total trim. Now we're at about 8%, something like that. So we'll go ahead and drop it and drive, brake torque it a little, see what the trims are going to do. And the long-term trim went up, but the short-term trim is correcting. Yeah, look at that. Looks like the short-term trim is correcting, and here our long-term trim's coming back down. We're looking much better. Those are really good trim numbers. It looks like we've probably got this car fixed. So I think the last thing we'll do before we call this one fixed is we'll take it on a test drive, watch what the fuel trims do under normal driving conditions going down the road, make sure they look good, and then we'll probably go ahead and give this one back to the customer. We're just out on a little bit of a test drive, keeping an eye on these fuel trims, making sure they stay pretty reasonable. They're looking good so far. I haven't seen anything jump out at me. I've been doing a few accelerations from 0 up to 55 because it seems like with the freeze frame data being 2,700 RPMs, 45 miles an hour, my assumption is that they were probably accelerating up to 55 when it happened. So I've done a few of those. Right now we're doing acceleration, and now I'm letting off of it, and looking pretty solid there. I think this one's gonna be where we can call it fixed. So gonna go ahead and head back to the shop, and we'll do a quick wrap up on this video. So I guess we'll go ahead and give this one back to the customer. Pretty confident that we've taken care of the P0171 code. You know, a couple of thoughts on this is, first of all, and I know a lot of people struggle with fuel trim codes because they can be caused by so many different things. You know, you can have dirty fuel injectors or low fuel pressure, mass airflow sensor, vacuum leak, O2 sensor. You know, there's just a million things that can set a fuel trim code. So I think the important thing to remember when you're dealing with fuel trim codes is to pay attention to what load range and RPM the code sets. And that's going to give you your best direction on where to go. Vacuum leaks will give you high fuel trims at idle. And if you power brake the engine or raise the RPMs, the fuel trims will get better. You know, if you've got a fuel pressure problem, weak fuel pump, then, you know, the fuel trims are going to get worse the harder you push the engine. So if you go out on the road and put the throttle on the floor, then that's when it's really going to give you, you know, your worst symptoms. With a mass airflow sensor, you know, they tend to give you fairly normal fuel trims, maybe a little high or a little low, just depending on how it fails, or at idle. And then when you bring it off idle and start to load the engine up, then you'll see your fuel trim start to climb. You can always try to clean it and see if they improve. This one did. Sometimes cleaning them, that doesn't help, and you just have to replace the sensor. As far as testing mass airflow sensors before you replace them goes, there's a few things you can do. The you know, the 1 gram per second per liter of displacement per 500 RPMs is a good rule of thumb. You can kind of check that at idle. You can back probe them and do some snap throttle voltage tests. You can take them out on the road, do a wide open throttle run, and look at your load PID and your upstream O2 sensors to make sure they stay high during wide open throttle. Make sure the load PID goes high. I didn't show you guys any of that in this video because trying to get this car done quickly, and you know, mass airflows is a common issue on this, so pretty comfortable going straight to the mass airflow sensor. If cleaning it hadn't worked, we would have had to do some more testing. But anyway, I hope you got something useful out of this. It's going to be kind of a short video. We got this one knocked out pretty quickly. I'm going to move on to the next one. So I guess we'll see this one again the next time it breaks.